Thank you for joining, everyone. We'll get started in just a couple minutes.
Still seeing that black boxes there.
Thank you, everyone, for joining today, and thank you to our sponsors. A couple of disclaimers real quickly here. The session will be recorded and it will be available on demand. So if any of you do not wish to participate in this point, please feel free to log off. We're going to get started with today's session now. You'll all be placed in silent mode. However, you can ask questions directly in the Q&A, and they will be addressed at the appropriate time later in the presentation. So please do submit those in the Q&A portion and not the comment section. And I will now turn the session over to Ko, who will be moderating it today. And please don't forget to submit questions because we will be giving away a free drawing at the end of the session today. Thank you so much for joining.
Thank you so much, Greg, and welcome. Thank you for joining us for this IoT World Security Day, Cybersecurity Days session on Zero Trust Security Frameworks for IoT. We've got a great panel today of speakers and with a lot of experience in this area of building trustworthy systems in IoT and industrial. So before we get started, Greg, did you want to kick off this brief video? Great, thank you. Well, first of all, let's thank our partners at IoT World today. They've done a great job putting on these sessions today, and we have a great lineup here. So let's get started. We've got a lot to cover. Here we go. So first, let's introduce the panelists. And my name is Kao Kaindek. I'm the CEO and Principal Analyst at Farallon Technology Group. I'll be moderating today, and Farallon provides research and advisory for OT cybersecurity as well as embedded and cloud-native cybersecurity. So let's start off with a quick introduction with each of the panelists, starting with you, Amir. Tell us a little bit about yourself and your company, and tell me the one thing that you're most looking forward to after things unlock and reopen with COVID.
Thank you very much for having me here, Keo. My name is Amir Elbaz. I'm the CEO of Beyond Edge. We are a Dallas, Texas-based company. And we revolutionize the space of enterprise networking. We make networks faster, more resilient, more secure, and more cost effective than the current options. What I look most about is actually going back to work and be with the team. I miss the hive. It's different working from home and different level of energy, and so I'm eager to go back to the normal, the new normal.
Absolutely. Well, thank you for joining us. Ellen Bain, can you introduce yourself and tell us
Yes,
what you're most looking forward to?
definitely. Can I start with that one? Because that sounds more fun. But Ellen Boehm, it's nice to be here today. I am with Keyfactor. I'm a senior director of product, and what Keyfactor does is we help our customers with digital identities, and we are a PKI as a service company as well. So we work with enterprises as well as IoT manufacturers in terms of securing their products and the devices within their enterprise. And most thing I'm looking forward to most when this is settled down a bit is traveling again. So again, kind of getting to see family and then also getting to see customers and having conversations. So thank you.
Thank you. Amit Biani from Smart Axiom.
Hey,
Tell us about yourself and the company.
hey, thanks, Georg. Thanks for having me on this awesome panel. I'm Amit Biani. I'm a CEO and founder of Smart Axiom. The Smart Axiom is like a distributed autonomous end-to-end security for the IoT devices. And we build a reliable and fast security mechanism for the really true zero trust solution for most of the company that we work. So we secure them and we permit. And I'm looking forward to be go out and travel and see my customers when the COVID will end it.
Great. Thanks, welcome. Matthias Hugel from Ubirch.
Hello.
Tell us about your look.
Yeah, my name is Matthias Hugel. Thanks for having me. I'm the CTO of Ubirch. We're a German-based company, and we focus on the question, where does my data come from and has it been tampered with? Is it trustworthy? So we don't trust networks at all. We try to enable markets by allowing our customers to give the data to third or fourth parties to enable new business models. And then these other partners can check whether they are receiving original and unmodified data at any point in time. And in combination with some blockchain technology, we also make sure that nothing can be changed in after it happened. And yeah, I'm sure we are going to talk about some of the interesting parts here in the panel. And what I'm looking most forward to is traveling, actually, just like Ellen. I'm a big fan of Asia, so I'm looking forward to also meet customers there again.
Absolutely. Well, thank you very much. And Shadi Razak from Angoka.
Thanks.
Coming to us from London.
Yes, from London. Thank you very much. So I'm one of the co-founders and the CTO for Angoka, which is an IoT security company based and headquartered in Northern Ireland, in Belfast. We are a graduate of the National Cybersecurity Innovation Programme and an alumnus from it. Our mission is ensuring the safety and resilience of IoT communication. So we manage machine identity and we ensure trusted communication are established over untrusted networks. We have our patent technology for securing communication between connected devices, using our embedded security authentication units, which provide with unforgeable unique identities for the machines. And it comes in different forms and shapes, mainly for retrofit to help patch the security of legacy industrial systems and infrastructure towards the movement to full integrated IoT infrastructure, whether if it was in smart mobility or smart manufacturing or critical national infrastructure. What I'm looking for most is to get rid of the face masks. It's driving me nuts every time when you go out in London, as well as traveling. I miss traveling. Similar to Emma and the others, I'm a big fan of traveling. And also our client base is across Europe, and it's not fun when you cannot go and see them face to face.
Yeah, absolutely, absolutely. Well, welcome, guys. I would say one thing that I'm looking forward to is traveling back to some of my favorite restaurants in, gosh, you know, I can probably list a handful of them just in Barcelona. But I'm also looking forward to traveling because that was the time that I would always do my email, and I notice my email just gets too backed up nowadays. So let's dive in and get started. We've got a great topic today on zero trust. But first, let's talk about what zero trust is. So zero trust. Amit, why don't you kick us off here and talk to us about what you think zero trust is and why it's important.
So, zero trust, like it's work on a very basic, simply. Don't trust and verify everything what you're looking for, whatever the source of the data, whether it is a user, devices, or anybody interact with the network, has to be verified. That's the basic fundamental of the zero trust that has to be implemented. So in our system, and what we did, we verify, and we giving a very unique identifier for every endpoints. Those are communicate with our system, and we verify through the gateway that we build it and the agents that we build it. We authenticate and enforce the policies, how they can access the system and how they can protect them. So the zero trust required every time to be verified and enforce the policies, and then you can visualize the data, who is coming and what is connected to the system.
You know, the history on zero trust is there was an analyst at Forrester that came up with the term zero trust networking, and you're exactly right. It was all about you know, limiting privileged access, doing a lot of the authentication of the users, and of course implementing a lot of the network controls. Ellen, I know you guys have been doing a lot around a concept called zero trust manufacturing, which I think is an interesting complement to that. Can you talk a little bit about what that is?
Yeah, definitely. So we come at this from the perspective of you know, our clients who are producing high value devices, you know, whether that's an industrial control system, a connected vehicle, and, you know, also medical devices, right? And so those devices need to be produced in a factory that, and you know, if there is secure keys and certificates that are attached to that device, that they need to be managed and handled in a very secure way. So we know, though, that the manufacturing landscape is very complex. So you as an OEM have contract manufacturers, you have global factories, you have supply chains, and there's a lot of moving parts around there. So when it comes to having secure identities built into your devices from the start and then managed so that no one can compromise your device in transit before it even gets to your end customer or even during operation, that it really starts at the beginning and how you're embedding a unique identity securely into the device from the beginning in the factory. So that's kind of the intro to it. I think there's a lot more we can kind of talk about, but it's really just how do you then establish a trusted way of embedding keys and certificates in these devices when you might not have complete control of the factory.
Sure. I mean, complete control in a factory or in the components. You know, supply chains, protecting supply chains is difficult in the manufacturing industry. Matthias, can you talk a little bit about some of your perspective on zero trust? I know you do a lot of work in across the board, manufacturing and automotive as well?
Yeah, so basically, in a way, we use infrastructure like Alan described, private keys and public keys. So PKI systems built into the devices. We use those infrastructure usually to make sure that all data that leaves a device can be verified at a later stage. That's one of the important things. And what you need for that is definitely a cryptographic identity that each device has. So it can basically just sign everything that goes out. And if you do that, you get a very nice feature from cryptography. You can use the data and verify it at any later stage if you trust the identity. So if you have a trusted identity, anyone who gets hold of the data that has been signed can verify it. And we extended this a little bit also in the way that we usually don't require end-to-end encryption. That's also one of the things that very often happens, because that's a very complicated thing to do. I mean, you can we basically never trust the network. So we let the data flow as it is, and we ensure that we can verify the data at any later stage and make sure that it can be verified. And that way, you can create a very, very large, even borderless system that doesn't even have special checksums except for the verification of where stuff comes from. And this applies either from the data going out or from the data coming to the device. So you can also prime the device to only trust certain identities and make sure that whatever receives is received, and maybe executes a certain action that
Right.
would change the way the machine produces something, make sure that it only executes it if it's from a trusted source.
Right. Shadi, you talked a bit about machine identities and ensuring that machine identities are unique. Can you talk about some of the challenges there that you guys have run into and tackle in terms of ensuring identities are unique and trusted?
Definitely. And I think if you look on the Zero Trust module, the main cornerstones comes is the identity, because without it, you cannot do the authentication. Without it, you cannot start trust, and you cannot build that trusted network or that trustworthy type of system. So for us, one of the main issues that we have found that the basic principle that usually comes that we are still looking on a lot of those machines and the devices in a similar way as the users. And we are using a similar methodology or similar approach towards what we use in the normal identity and access control. And that's where we approach it in a way different, where as similar as people have their own fingerprints and their own DNA, we help the machine to generate their own identity or root identity based on the physical characteristics of that device. So it's based on the characteristics of the device, which you will have a lot of devices that they share parts of it, but also at the same time, they have their own unique characteristics that can use to generate that root identity, which from it, then you can be able to generate a number of pseudo identities that you establish it and you use it towards different type of communication and different type of networks at the same time, which means you have a total resilience of the different segments of the networks that they are involving in and communicating. And that have helped us a lot to provide such a solution in a retrofit that help legacy systems to bridge these gaps and not need to go with what we have now, because the current cybersecurity approach towards securing industrial systems or legacy systems, it's not fit for purpose, to be honest. And we try to struggle all the time with it. And bringing normal IT towards OT doesn't always fit exactly. It's more like, fitting a square peg into a rounded hole most of the time. And that's where we tried to change that principles. And we have deployed it on a number of, industrial systems, on even within the vehicles itself, where you add the last line of defense and the starting point. So the root of trust of that network or that communication comes from the device itself.
Right, right. Yeah, I mean, identities are important, and I want to dive into more depth there before we go there, because that can become pretty complex pretty quickly. I want to ask Amir. So we've talked about zero trust. And the importance of it. We talked about identities and managing identities and machine identities. We've talked about data and ensuring that the data that is being generated and sent over untrusted networks can be trusted. Talk about what you guys are seeing from the network side in terms of trust and building trusted networks.
So IoT has affected two main areas. One, of course, is the trust we're here, but also the sheer number of devices coming to network, and they're all consumers of that network, can overwhelm. So the networks, zero trust is a paradigm shift, right? It's not anymore the old approach is like whatever the organization, it's trusted. So if you're there, and then outside the organization, it's not trusted. Now, your network has other locations, people working from home. So the whole thing in a paradigm shift, the network needs to be, it's the pathways, those smart pathways between those devices out there and then the controller. Now, we see edge computing becoming for those edge devices becoming more and more important, because as they generate more data, a lot of it doesn't have to go to the cloud. So the network needs to be very agile, very secure to identify. So continuously auditing who's connected to the network, what is connected, looking at analytics, is like who's the top talkers, what are we going to do? Are we allocating enough resources for the device to do its job? So it's not only the security, it's like mashing it with the effectiveness, mashing it with other elements in order to provide a perfect picture of what those devices are meant to do, right? I mean, those devices typically in the IoT, in the industrial IoT, is adding productivity and safety. So we need to give those smart pathways to and from the controller in as little latency as possible in order to make it effective.
Right. I think that's an interesting concept of networks needing to be more agile. We're seeing the convergence of several different compute models, right? We went through the bare metal to cloud and then IoT, but now we have edge, and all of it is actually happening and being integrated together now for applications, which makes security much more complicated. Even the notion of a machine identity could be extended from a physical device to applications or containers as they're deployed. Those are being deployed across the edge, right? So I think it's a very interesting topic in terms of not just how do you manage the identities and ensure the data that's being generated and stored and transferred is what you think it is, but also this notion of agility and how do you get these systems to change and be more intelligent. Let's talk a little bit more about, let's talk a little bit more about what impacts zero trust, because there's a lot in there in terms of architecture and the devices, the operations, and of course the network. From an architecture perspective, you all have founded or are involved with companies that are very much at the cutting edge here. What is it that has been missing from the security architecture, especially for IoT, that you believe is impactful or important? Matthias, you want to tackle that?
Yeah, interestingly, most often the security at all is missing. That's one of the issues. If you take a look at the deployed IoT devices, you will see that very seldom they have capabilities for real security. It's one of the bigger issues that we face. So we are we are providing, since we are providing a mixture of on-device firmware additions and networking and capabilities in the cloud, it's very often the case that even giving a device some identity is a very hard thing to do. So it's not even that simple and possible. We are betting a bit on the future there because things are moving. It makes it hard for retrofitting, which was just mentioned here in the call as well. One thing that we tried to tackle this problem with is that we integrated with some SIM card manufacturer. So we are using the identity that can be put on a SIM card, which is a very secure device, and can be fit into IoT devices, giving it a secure identity and even offloading some of the cryptographic functions that you need there. But this is, from my point of view, one of the biggest issues to actually be able to give security to the device. I mean, if you look at at some of the numbers, even making a secure SSL connection, you know, like you're known from the web, a secure web call, you want to transfer data from A to B, gives you such a high overload or overhead in terms of data. Most of the, if you use mobile connections, most of the IoT connectivity providers, you would use up the volume that you get in a very short time.
Yes, you know, we had a question just come in that was related to SIMs and eSIMs. Can you talk a little bit about the role of eSIMs in this and whether you're working with any of the eSIM technology as well?
The eSIMs are very interesting for us, and we're trying to get away from the plastic cards actually, because one of the problematic features of normal SIM cards is, of course, you can take them out. I mean, there are measures sometimes that protect them from taking them out, but if you take them out, you basically remove the identity. That's why we're looking at eSIMs especially because they have a number of interesting features. One is they are soldered onto the device, which makes it more secure. So you have to open and actually forcefully remove it. And the second part is most of the eSIMs or EU ICCs have features that allow us to also put stuff on the eSIM after it has been fitted. So you can basically send data and programs to the eSIM and make sure that it's on the device in a protected profile, which is not so easily possible with normal SIM cards today. It's a called over-the-air update feature, basically.
Oh my gosh, right, over the update. We'll get there. But this notion of device enrollment and taking those first steps to convert the embedded identity that's been issued to the device, perhaps at manufacturer, and converting it into something that can be associated or used to create a real machine identity. I'd like to simplify that for people, because I think that is one of the biggest challenges for people to get their heads around. How does it actually work? Let's see. Shadi, do you want to talk a little bit about how that piece works, that first stage of that device enrollment for you guys, how you make it easy?
Sure. I mean, this is one of the main challenges that you would find actually, and I agree with Matthias on most of the point that he mentioned, that, you know, enrolling these devices, and you have devices already are built in and the asset management for it, but enrolling them and starting them to build up. There's always numbers of ways to do it, and there's approaches that you can implement, which, you know, similar to zero knowledge proof, where you put, you know, part of your initial secrets or ingredients into the device, and the other parts will be available into a remote system. And as soon as you put the device into the network, just initiating doing that connection at the beginning will initiate building those identities. Now, of course, these processes, and in order to avoid, as you highlighted, the issue of continuous provision, and then you will have to look on other security measures that are put in place, and then you need a centralized point to manage that. I think the key where it comes for us, where we do it, we decentralize the process, and not not using blockchain, but using more same principles of distributed ledgers in that part, and depends on other systems that already these devices are working with that have established certain parameters for them and who they want to talk. So if you're talking on a vehicle and within the infrastructure of an old vehicle, you know, all of the devices that are being put on it and all the software that run will tell the device which other devices that it will be communicating with in general.
Right. But
So,
I guess what I was asking was, how do you do that initial seeding? Like, what is at a, you know, not at the nitty gritty detail, but
yeah.
what is that user experience for someone working with you guys? How do you make that simple? Creating that device is.
Yeah. And that's fine. So for them, when they are usually getting the devices, or they're going to roll out the identities across the different devices that they have, they will approach a certain platform, a cloud platform, where they will be requested to input certain information into it that will act as the initiating or part of that source of that seed. And then just by clicking initiating, the devices will establish a secure connections to that cloud platform and kickstart the process. Now, that's what they need to do at that point.
Great. Okay, so Ellen, you know, so much of this ends up being how you can manage things like keys and certificates, right? And it's not as simple as saying, I have a CA, I have a device, I'm going to now go get a certificate and put it on there, right? It's a tiny little device, or it's a server class system operating a robot, many, many different use cases. Or it could be, you know, 50 million ECUs that you're trying to stage. Can you talk, Ellen, about how you guys do it? Really that first piece of enabling someone to get that identity on the device and then work that into how they use that from a more of a traditional PKI perspective.
Yeah, definitely. Yeah, so for clients that are using PKI as the backbone for certificate creation, we work with them to kind of understand within the device yourself, within that PCB that you have, and what is the operating system that you're running? What do you have a secure element, or it's a TPM, a trusted platform module, where you might be able to store keys in file store, for example. We talk about doing an on-device key generation as long as there's sufficient entropy to create a private key that is unique and tied to that device. And again, enough entropy so that it is sufficiently random so that it cannot get cracked. And that is, again, using the technology and algorithms available to us today. And so kind of do the best that you can with the hardware that you've got and the randomness available, but then have a methodology over the lifetime of that device, which in industrial cases, we know can be 15, 20 years for big industrial assets and so on. So making sure that you have a way to update the keys, update the root that you have built into your entire fleet of devices, because the algorithms we have today are not as strong as they're going to be in 5 years, 10 years. And we hear people talking about quantum computing coming, and when that is going to be able to break the algorithms that we have protecting all of those unique identities that we've all been talking about. It's kind of a scary thing. You've got to be able to have that method to automate and update, your entire set of credentials. So that's kind of how we think about it from Keyfactor standpoint, is ensuring you've got that unique identity and then the life cycle piece over time.
And I know a key piece of that is being able to take some sort of software client and integrate that with the firmware and work with the manufacturer to get that on there. Once that's on there, then you can actually run a lot of those functions to do the on-device key generation and kick off all of the, the CSR submission to get a certificate and all of that, right? But I think one of the key things is integrating and partnering very closely with the device manufacturers so that you can get that right code or client integrated with their system to make all of that work, right? And once you do that, and you have a good way of managing the keys and certificates, all of the other functions, whether you're using blockchain, a distributed ledger, or encryption, just works better, right? Amit, talk about distributed ledgers and how you guys handle that first piece again of feeding that device with the capability to begin participating in network and securing it with the distributed ledger technology.
So, our basically distributed technology start with like how you defining the identity of the devices. Like, so we create a mechanism on the endpoints, like you can create a unique identifiers without looking any certificate and keys. We generally looking a mechanism called a puff to make create a reading like when the device booted, it read the certain characteristic of the devices and generate a unique identity fingerprint of the devices. And we generate those tokens and we share with our edge network, and we create a device block in the system. So those block is always, whenever the device come on a network or go off the network, it verify those blocks. So we always have two kind of a token that we generate. One is when the device registered to the system through the manufacturer when he bought the devices. And the second time when the device go onto the field, when they are activated and by end user or end customer. So we add those activation token in the system. So we verify those at the moment. Okay, this device come on the board. We need to identify his identity that registered by the manufacturers, and then this is the activation code is generated. That combined in our distributed ledger system. After that, we take those devices on the board, and then after that is the block that we created is an immutable blocks. Once it's registered, it won and then registered on the master ledger system. It never go away. So whenever device go off the network, and whenever the batteries die, it always identify those identity on a system, and that will go move forward. And then what we did, like we add some more additional patented technology. So our basic philosophy is that every device or the network should work on the same time domain. So whenever the device is started, we synchronize all the clocks between the device endpoints and the edge and the cloud, and make sure those are working on the same clock domain. And whenever the transaction generated by or any communication is generated by the devices, we authenticate looking on their previous history, what are the current transaction, and we verify those transactions in a system, and then after we take it and put into our system. So that is the way we create a very embedded blockchain system, basically embedded distributed system that works in a multi-chain, like 2 chain we created in a system. That is one is work for identity, and the second chain that we use for a distributed network, that is called a communication channel, so that we verify the communication at the moment that the data comes.
And Amir, how talk to us about the agility side of it. We talked a little bit about that, but if the system has more intelligence around identities it can trust, right? Identities that maybe have a higher level of authentication assurance than others. What can you do with an SDN to make that network stronger, or to adjust to a changing network where entities are connecting in and out?
Yes, so multiple things actually. But when you address it, you need to take the complexity. It's a very complex, right? You have a multitude of services and multitude of devices, etc. But you need, what we do it with a single management tool, a single pane of glass that you can see everything, and it's built like a Google map, so you can see everything, what they're connected, etc. You get reports live. But what we do in this case, we can integrate multiple tools. For example, MAC authentication. We can have, a list of approved devices. So, whatever identifier is, the network will pre-approve you before. When you try to connect, you say, oh, I'm sorry, you are not. You're going to put you there, and I'm going to notify the administrator that there's somebody who's trying to connect and he's not part of the trusted network. So this is where we go into zero trust. You're not there, you're not there. Another thing, we do micro segmentation. So we do a lot of, VLANs in a situation where, like,
Question up on micro-segmentation, so great.
Oh, yeah. You're welcome. In the sense of, like, have different level of authorization. So whatever the architect of a network, we give them the tools to think big, but we look at the bottoms up. We start as a company. We always address, it's like, okay, what is the most mundane, little, most basic thing, and build up the network, instead of, like, a lot of the traditional networks that are coming from the cloud. In the cloud is all top down, right? It's like this approach. So we taking approach of a bottom up, and this is where the agility, because we know how to deal with, in a single local area network, tens of thousands of users and devices. And you need to just chew it one at a time, but a very fast way. Elements of machine learning and, of course, artificial intelligence, where, like, you can make decisions based on predetermined rules. Okay, this device, not familiar with that, but these are the ranges, of things that I can expect, and etc. So you can have some rules that will give the system the agility that it needs to process things very quickly. I hope I answered your question.
Yeah, no, absolutely. I've often thought that for devices that connect onto a network, some of the networks may be private networks, some of them may be public internet networks, cellular networks, but oftentimes we treat a lot of the devices the same depending upon where they're coming from and where they're trying to get to. But with all of this discussion around machine identities and being able to really validate and verify that this is who you think it is, it strikes me that there should be a better way to manage the economics of networking based on how confident you are in that device being authenticated, right? If you truly trust me because my identity is tied to something in hardware, it's different than I'm just coming over something and I have a self-signed certificate and you don't know who I am, right?
So you talked about the economics. At the end, security is definitely number one in the mindset of a lot of the executives. It doesn't matter C-suite, there's a security breach or there's a problem, you're going to lose your job. It's not what the bonus you're going to make. So security is definitely a concern. But then the second part is, like, the economics, like, at one point, this is, I'm going to go out of business if I'm going to follow that model. So we are a great believer in the concept of a hyper-converged local area network. So basically a very, very robust, but one network in a greenfield environment. We are big proponents of a fiber-based local area network. So it's passive optical LAN, as they are in the industry. And but having the machine, or having our solution, our technology, give an oversight and everything, every little port, everything is connected based on predetermined set of rules. Setting up VLANs, where we talked about the micro segmentation. So I'll give an example. We had a very large hotel chain, and what they noticed, that a lot of people watch their Netflix. They don't want your, what you have on your, content, but they want their own content. And Netflix doesn't have, offering to hotels because you own the content. So what they did, they put a Chromecast to every TV in the hotel, so you can project your own content to that TV. But how do I give that Chromecast just a path, to what he needs to operate to stream that content with the appropriate security? Because I don't want somebody to come to the Chromecast. So this, how you create this micro segmentation, a pathway only for what that application needs and not more.
Interesting. So we've talked about a lot. We've talked about the architecture and where that's fallen down, especially around identities. We've talked about the devices and device enrollment and how there are solutions that simplify that, the importance of the operations and managing those identities and network. A quick question here. Well, I don't know if it'll be quick, but to you guys. We've talked about PKI and blockchain. Are those things that you see competing, or can they work together? Who would like to take that? Matthias.
Maybe I can start. I don't see them competing, not at all. You basically need a PKI base to run a blockchain system, because the blockchain itself, in the most basic sense, is just a data structure that contains something. And everything that's within these blocks, I mean, that's why it's called blockchain, needs to be authenticated before it enters it. It needs to be verified that it's correct. I mean, you have in the blockchain system, you usually have the issue that you can do a transaction and store data in a blockchain, but if you don't verify that it's authentic, you have trash in the blockchain. And then you can have it forever there, and it's not worth it. So we need a PKI to actually validate, sign, and check the data that before it enters the blockchain, and also identify all the players related to the blockchain transactions and operations.
Thank you. Great explanation. Okay, we're going to change gears here a little bit. The Industrial Internet Consortium has what they call their trustworthiness framework, and it goes through a number of ways that, from the perspective of an industrial company and operator, how you should think about building trustworthy systems. So there are 5 concepts around that make up trustworthiness: safety, privacy, reliability and resilience, and security. And Greg, I want to see if you can help me to do a poll right now. I want to ask the attendees, what are the most important, or what is the most important consideration you have when building a zero trust framework for IoT? Is it safety, privacy, reliability, resilience, or security? What's most important to you? If you could vote on that and give it some time, maybe 30 seconds or so, Greg will help us see the results. Okay, this will be interesting to see what people say here. Wonder if everyone will just pick the same thing.
Security.
Okay, let's see what we have here. So 9% said safety, and 5% said resilience, and 9% said safety, 9% said privacy, and the next one was reliability, and security was the top one. So security is still obviously very important in building trust, and I would say foundational to ensuring safety and reliability and resilience. Though the others, I think, tend to connect more readily to the business, but there's no question that security really can address and be a part of the whole system. So, interesting. So, I want to change gears a bit here and give the audience a little bit of a flavor of, more specifically, how to think about trustworthiness, what your experience has been in deploying trustworthy systems in different use case environments. So we'll start with manufacturing. Let's see here. Trying to advance this. Greg, can you advance that? Can't seem to. There we go. Okay. Zero trust manufacturing. I know Matthias, just because you and I were chatting about it earlier. Talk to us about digital twin. I know you've done some projects with digital twins, and tell us what a digital twin is and what some of the security implications were in handling that project.
Well, the digital twin is actually something very basic. You have a machine, for example, that does something. It works on creating some goods. And the digital twin is basically the in a copy or on a mirror of what the actual machine is doing in your cloud system, for example. So it's basically the mirror that gives you the ability in the cloud to work with the machine and act like with it like with the machine, but you're actually working on the digital twin of it. And it allows you to basically also control the machine. And the issues that we face there is the following, that of course, usually you have a network in between, so you need to make sure that your connection is secure between wherever your digital twin is managed and where the machine is. But also you need to make sure that the mirror is always correct. So you run into really big issues if, for example, your machine is doing something and your digital twin tells you it's doing something else. So you could be producing a very high value medicine, but your digital twin tells it, but in reality, it just produces something very dangerous. So you need to make sure that this is always secure. And there's a gap between this physical world and the real world. And we need to make sure that we can control the trustworthiness between the real world and the digital world, and basically between the real and the digital twin.
Sure. It makes me think of what we call replay attacks, right, on HMIs in factories, and
that's one of the things. Yeah. So. Basically, one thing we already talked about, we give the digital, the real device basically a digital identity, a cryptographic identity, and we have this copy in our cloud, and we make sure that all the data that comes from the device or travels to the device is always signed with some cryptographic identity. One thing, for example, that we do in our system to make sure that stuff like replay attacks or suppression attacks are not easily happening is we are basically creating little chains of data. So whenever you send some data from the device to the cloud, it's connected to the information that was sent before, and that again is connected to the information sent afterwards. And all this is cryptographically signed, so you can easily detect if something is missing or something comes in as a duplicate, and makes it much easier to detect whether there are issues, for example.
Sure. Amit, talk to us about the role of, with this just notion of a distributed ledger. If you have different devices within a factory floor,
Mm-hmm.
and they're all part of a distributed ledger, they're all part of a blockchain, they're all making sure that the whole system has not been, or that you can trust the system even if something has been compromised. Can you talk a little bit about what you have seen and what insights you've gathered in terms of deploying that in a manufacturing environment?
Yeah. So, we did one of the good project with the Toyota to on their Lexus plant. When we went there, like the plant was like working on like one production line has a multiple processes are there, and every process are collecting the different sense of the data. It's like every process has their own data, and they create the island of the data warehouses, and they are storing those data. So the data volumes are so high, like it is connecting like around 1 terabyte data a day, and we are around 65,000 data points. And then you have to manage like they said like if their downtime has happened, they lose a lot of money, because what happened all across the production plant has to be slowed down. So that's what they want to be protected. So what we did, we proposed them like we can create a kind of a distributed network across your production line. We can connect it we creating an edge network, and then we creating a decentralized network between the different production line. So we group them into in a two different way. One is like a physical view and the logical view, where all the operationals are working, and And the logical we controlling the device securities and their communication. So they connected with the PLC devices, the SCADA devices, and all the Wi-Fi devices come into the control layers, and then all the business where the data are moving. So when we enforce the policies, and then we enforce them like how your data will moving from one process to another process in our register. So we verify every communication, and we replicated this data between the different production lines. So they have a real-time informations are available. And then we push that data back to stream that data back to the cloud. So they are analyzing that machine learning, and they are analyzing the system and pushing back to the edge. Okay, this is what the information that we receive, and this is our AI model supposed to do. Our MI model was supposed to force those processes. So a simple example like the pen brush shop area. So the pen brush shop has like a multiple different sensors and devices are they installed. They have a humidity, temperature, and controlling the fans. And then after they have a cameras also there. So they are monitoring every car they painted. It must be a uniform. If there are any bubbles or any moisture will come there to repaint it. So that's that they want to know like how this is happening and how you are securing the data. That was a very important. They asked us to do that on that.
Interesting. The next thing we're going to talk about is automotive, and I'm going to have Shadi and Ellen talk about that. But before we go there, Amir, industrial IoT is a big thing, obviously connecting factories, smart factories together, 5G, private 5G within factories. What are some of the trends you're seeing with networking and SDN in factory environments?
So we definitely see a lot of interest on 5G, private 5G and CBRS in the United States. And, it's kind of the swing between, the network enable new types of applications like happened with LTE, right? LTE came and then the video start picking up. Now we see 5G and people see the possibility. And I believe in the world of the industrial part, we're talking about augmented reality where you come in and you see the machine working when you look around, and sometimes you got a lot of the. So we're talking about speed that will enable new types of technologies. 5G, the way I look at it, is as important almost as the Industrial Revolution, because for me, 5G is how we interface with machines. It's not like we're creating machines, it's how we interface them in a much accelerated way. Now, the Elon Musk, chip in the head will go and we talk without, programming. I don't know if it's going to be that far, but 5G, you never know. But 5G is, something that will change the way, factories and anything industrial will work with new types of applications. Some of them that, some of them will be the most successful we're not even aware of. But there are some developers out there thinking about something crazy that will take this speed and distribution. We see, airports, ports in general, not just airports, for security, not the security of the information, but literally, homeland security kind of a thing, taking off. So network will enable faster, more important application that we have today.
Thank you. Okay, let's go on to something that is really interesting, which is around automotive. Shadi, you guys have done a lot in here, from working with companies to looking at kind of the whole ecosystem here. Tell us about what you're finding and share some interesting insights that you found about zero trust in automotive.
Thanks, Kia. I mean, zero trust in automotive is early days of maturity, I would say. I mean, it has different, you look at the OEMs and the manufacturers of the ECUs, and each one of them is trying to adopt a different way or a method to secure the devices or the electrical circuit units that goes into it. And you know, within over the next 10 years, we will have on the road a different type of vehicles between the legacy vehicles that are totally not connected, the connected vehicles, and then the early levels of autonomy. And the whole car architecture over the coming 10, and that's what we are seeing, more will start to change to have a more powerful or computing powerful ECUs and a number of less powerful sensors across the organization instead of the current architecture. And the idea is more about, for them, when they are looking on that zero trust, it's still the root of trust sits on the application layer, or when you look on the vehicle, most of them. And still that is an issue where it's important. It is changing with some organizations. So we are working with, I cannot mention the exact name of that organization, but with a very famous car manufacturer from the Bavaria region. I think Matthias will know them straight ahead. And another one, you know, American with, you know, an oval blue logo, let's put it that way, where we are looking on implementing this, what we have, where the ECUs in the car, they generate their own identity, and then collectively they generate a unique identity for the vehicle. And then when it's hit the road, it can communicate easily with other vehicles. Or, well, I'm not going to say easily. It can communicate in a trustworthy way with other vehicles, as well as with the critical national infrastructure. At the moment, while we are talking, you know, our engineers today was with, you know, the American car manufacturers and work manufacturing group in the UK, and we were running a test, a real life test about running a number of attacks on critical national infrastructure and trying to redirect vehicles and impersonate vehicles into these networks. And the idea, when you look at it, and it's quite similar to what Samir has said, to Amir, what he said about the complexity of the infrastructure and that network. Because you have the vehicle itself that's going to become a collection of IoT devices and different levels of IoT devices, from class 0 to class 3, as in the sense, you know, sensors that they don't have any memory size, they don't have any computing power, to something in between, to a very advanced one. And that is an entity on its own that you need to ensure its safety. And in order to ensure its safety, you need to ensure its security, because it's heavily connected and built. Right. And it's a similar manner to what Amit have said. This is what we are creating within the vehicle, but we are building it from the physical layer, which is the hardware itself, building the ledger between the devices. And then we take it up a higher level where we sync between those ledgers of the different vehicles and the critical infrastructure or the roadside units, which allow you then to do the micro segment of the infrastructure and trace a vehicle anonymously without exposing the privacy of the personnel who's riding that vehicle, and have a better understanding of the journeys and be able to do an active routing for these vehicles based on the infrastructure, predicting the different type of workload that goes through. So you have the identity flow, and that's where the excitement for us comes with the current car manufacturer, is that identity from an ECU, it can flies all the way across the network outside of the vehicle and be able to participate in the bigger identity of the vehicle as well as the network.
You know, one of the key areas, if you imagine you have, you know, could have 100 ECUs on a car, a gigabit Ethernet network, and 5G off of the car, right? There's so much you can begin to do from a monetization, right, and et cetera. But you also run into this scaling issue, this extraordinary scaling issue.
Yes.
Ellen, can you talk a little bit about scale and what you guys have run into in terms of automotive and scaling, and some of the big problems that automotive manufacturers are dealing with?
Yeah, definitely. Yeah, I mean, I definitely agree that I think it's early on in the whole journey, but we are definitely talking to more vendors who are looking for this unified strategy around, you know, certificates and identities within the vehicles, specifically for in-vehicle communication tied to the ECUs, being driven by their if you're an ECU manufacturer, being driven by, your end customer or regulations within the industry. And I think some things that we're starting to see is also around the requirement to be able to have that updatability piece in the event that the underlying root or crypto that's in the devices needs to be swapped out and in a very quick manner, so that you don't lose operation of, again, if it's your industrial piece of equipment, or even the vehicle itself. If something was to happen when someone is driving it, that could be catastrophic, right? So having a way to make sure that the underlying platform and infrastructure that you have used to build all the identities in crypto into your devices is able to be swapped out very efficiently and very quickly. And we have actually performed studies showing this specifically in the vehicle industry, and swapping out keys and certs, and in a matter of a day for over 500 million. So I think that's also important when you're thinking about how you want to architect the overall system, so that, again, having those unique keys per ECU, having that right code signing, infrastructure, and then the right way to kind of provision these keys in the factory is really important. But then that's just the beginning of it. So don't forget about that last piece where you've got to be able to, if something ever occurs, swap everything out.
Right. I mean, and that scale is incredible, right? And it's just going to continue to grow. On the other hand, you also hear about companies like Tesla that are monetizing this by selling substantially the same car, and people can simply get an upgrade, $3,000 or to upgrade the software, right? But to do that, you have to have very, very strong security on the vehicles. Okay, let's talk a bit about smart grid and energy and scalability and privacy. It's a little bit different than what we've been talking about, manufacturing or devices, but this is dealing with large SCADA networks. How can electric utility companies, for example, and municipalities think about zero trust? Who would like to take that one? Matthias. Oh, you're on mute.
Sorry, I can give a short start. I think this is closely related to what we just talked about, the mobility. We did an interesting project once where we connected cars with the energy manufacturers, because one of the issues is if you have lots of electric cars, you need to be able to put energy into these cars. And our grids today need to be managed in a way that the energy is at the place where you need it to be. And zero trust is interesting there, because you have cars which have an identity and they can talk to the network and tell it, I will be out of energy in like 100 kilometers. And then you basically have the opportunity, and that's where this slide comes in, to tell the networks that there is a trusted entity which will come and would require a lot of energy to be quickly charging the car again, so you can drive further. And this is an interesting issue, because you have lots of different car owners and manufacturers, and they all provide their own identities, and somehow you need to connect them and make sure that you trust someone who owns one of these identities to be able to charge your car, or the other way around, to actually get some energy. And I think this is kind of an interesting thing, and this goes beyond just the car and some of the energy providers itself, the large ones. We do see in the industry an interesting movement to include more and more small energy providers. And you basically have to be sure that the energy that you get, which is basically just a number, is actually the amount of energy that is put into the network, and that you can then sell at another point outside of the network again. That's where you basically have again this issue of, do I trust the energy provider that he put in a number of kilowatt hours, and do I trust someone who just uses this energy? And then and because this influences how you can create payment networks that work.
But that also seems like it just lends itself perfectly to that notion of the distributed ledger,
Yes.
right? Able to use blockchain, anticipate, build it all. You're not. It's not about trusting one single entity, but having confidence that you would have to compromise a lot in order to, impact any other monetization.
Yeah, this is like one of the customer that we discussing, that they build the electrical charger. So they wants to be used, like they say, like we want to use your edge plus your cloud solution to build a distributed network across our multiple electrical charger, and make sure that customer will connect it through that, and then we charge. We want to replace some of our hardware with the software, soft identity on a system, and then they can charge on a distributed ledger system. So they can connect it with the electric company, and they can connect it with the car manufacturers who's just providing, and they wants to connect with the electrical charge company also.
Incredible.
I think the question just on that one, just to add, Kim, it's more on what you are trying to achieve, right? Because on your smart grid, you're talking in a very complex environment. You're talking about very dumb sensors towards more advanced gateways, towards SCADA system, PLCs. You're talking about devices that they are still running Windows 98.
Yeah, absolutely.
So, yeah, and I think that's the trickiest part of it for the zero trust environment and for the owners and the management of the SCADA systems, about what they want to protect and what they want to achieve from it.
Correct. Okay, we have a limited time left. In the time we have left, I'm going to, starting with Amir, take a minute here to just provide some of the top things that you would recommend to companies that are considering building out their own zero trust framework for their businesses to support IoT. What are your top best practices?
Well, I think I mentioned it earlier. You have to have a holistic approach, not just what's happening now, but look at the future. And what Shadi was saying, I mean, you don't want to be in a few years we're deploying running Windows 98. So you have to build a foundation, for the network, because it doesn't matter how good your applications are. If you don't have the foundation and network to put, and funny, you put the roads here on your presentation, because you might have the best Ferrari out there, but if it's a dirt road with bumpy one, that Ferrari is not going to go more than 30 miles per hour. It doesn't matter how good it is. So you need to lay a really good foundation, take a bottoms up approach, and look down the road. And might want to invest a little bit now, so you don't have to rip what you built now a few years down the road, because the application is going to move so fast. And the last but not least, be humble, because you don't know what you don't know.
Matthias, how about you?
Well, one of the things that we try to help our customers with is also not put the security in the way of that things work. That's one of the biggest things. We tackle this in two ways. One is we are basically a sidecar to most of what they do, and we never see customer data. So we try to stay away from the actual data they own. They have to handle it themselves, and we try to handle the checking and everything outside of the actual data flow. And that way, even if something goes broke at our side for some reason, which I hope never does, they would be able to still work, and we have time to fix things, and can maybe just put a flag up that something happened or something. So privacy and confidentiality, basically, for our customers.
Great. Shadi. Oh, you're on mute.
Yeah, always. From my end, I think it's from a best practice, I look for zero zero trust framework more as an enabler for us to move from what we call security today towards digital safety and build the resilience into a system. So because of that, you need to map your cyber and physical system, first of all, build the identities and build a good management system for that identities, because based on that, you can segment the network for the service on a conceptual level or any different levels in our principles. And I agree with what Matthias have said. One of the main things I think where the CIA paradigm is a little bit changing nowadays with the IoT and the industrial of IoT. It's more on availability and integrity than just the confidentiality, especially if we are talking on whether critical national infrastructure or mobility or medical devices, the availability of it and the integrity of the data that they are receiving, the integrity of the functions that they are doing on it, it's critical.
Thank you. Ellen.
Yes. In summary, I would say just again, establish that unique digital identity for each device bound to a cryptographic key. Make sure you're doing authentication so that only legitimate devices and people can connect in, use client-side certificate authentication. And then just make sure you have this updatability of your cryptography over time. And that's what we call crypto agility. And it's super important because these long-lived IoT devices are out there, and it's basically, as an OEM, your brand, your maintenance, your warranty. So super, super important to make sure you can handle that and do it at scale.
Love it. Amit.
Hi. So what as a smart axiom, I was definitely like a zero trust is the next way to secure the IoT devices. If you really want to do digital transformations, so we need to build a system that have a strong policies. The policies that how you design and how enforce the policies at the edge, and how you're going to be define a unique identity of the devices. That's a very important of the system. So that because IoT have worked in a very heterogeneous system, it crosses the different boundaries. Those needs to be authenticated, and that those data should be have integrated and authorized from some other methods that we have to apply. So that's where we can have a real digital transformation on the IoT side.
Excellent, excellent. Well, we are at time. Thank you for joining us today, panelists. Thank you for a really great conversation. This was a great session. Thank you to Beyond Edge and Key Factor and Uberch and Goka, Smart Axiom, and of course IIoT World for a great session on zero trust security for IoT. Thank you all for attending, and we hope you'll join us next time or on another session. Thank you very much. Have a great day.
Thank you.
Thank you, guys.
Thank you.
Thank you.
Thank you.